Okay, hello guys, and welcome to this example. In this example, we are asked to find the current that goes through the 10 ohms resistance. So we have a circuit, and there is a current of 1 ampere entering this node. Then it is going to split into a current that goes into 10 ohms and a current that goes into 47 ohms. Now this example is interesting because you have to realize that this current, which is by default is going to be bigger than the current in this 10 ohm resistor, is going to be bigger than the current of 47 ohms resistor because of the resistances and their difference. Now this current is not going to be the same as the current that goes here. Why? Well, we can redraw this circuit since this is actually a single node, and those two currents are entering this single node and coming out into a different values. So this circuit can be maybe blue. So this circuit will be something like this: a resistor meeting another one. Okay, my choice of the color is not successful. Another resistor and the third one or fourth one. So the idea here, which is very important, is that this current here is something else compared to this current here. They are not the same. When these two guys meet here, they will split again, but into different ratios according to these resistances. So the current in the 10 ohms resistor can be calculated in various ways. One way is we calculate the total resistance of these two guys. Actually, we will do it into two ways. So first method or way, if we calculate the total resistance of these two, that is 10 times, that's times 47 over the total, which is 57, that equals, maybe I can use a calculator to do that. So 47 times 10 over 57, so it is 8.25 approximately, 8.25 ohms. So this is the total of these two if we are going to make this circuit something like this: one resistor, another resistor, and go back. So 1 ampere times this resistance gives us the voltage across this resistor, and that voltage is 1 times this, which is 8 volts. So the current is going to be 8.25 volts over 10 ohms, which is this resistance, and that equals 0.825 amperes. And that is logical, since this is much less resistant than this one. Then it has to get the bigger portion of the 1 ampere, and that is almost 82 or 83% of that. Another way to do that is just to calculate a current divider. Okay, and the current divider rule says that the current I in the 10 ohms equals the total current 1 ampere times the other branch's resistor, which is 1 times 47, over the total of two resistances, that is 10 plus 47, and this equals 47 over 57, which should be 47 divided by 57, again 8.24 or 0.8. This is what we got. This is it. This is the number, 0.825 ampere, as we did before. Now, a modification of this problem, if we remove this part. So if this node was removed, I will leave it to you to think about it. What happens to this current? How much is this current going to be? Is it going to be bigger or smaller than this one? And another question is, what is the voltage difference between this point and this point? Okay, what is the voltage between the point A and the point B? Okay, this is one problem. So please think about it, try to solve it. If you have any problems, you can ask me. A second idea or a second problem is the following one. So in this problem we have a load, and this load is connected in parallel to a resistor, and both of them are connected in parallel to a voltage source, and we have here what we call a fuse. A fuse is a small device introduced into lines to protect the devices. For instance, if this was expensive hard disk or multimeter or whatever a load is, and you want to protect it from over excess of current for some reason, we introduce a fuse here. If the current goes beyond the device's rating, then the fuse is burned, and the fuse is very cheap compared to whatever a device is. So in this problem we have a load, and the total circuit cannot have a current more than 2 amperes. That's the idea. And the question is, what is the minimum value of the load or the maximum value of the load that will achieve that? So if we go beyond that value in terms of maximum or minimum, what happens to this to the current? How much is the current going to be? It should not exceed 2 amperes. Alright. Now, so this is actually this is the fuse value. It is not the current that goes in. The question is, what should be the load so that the current does not exceed 2 amperes? Let's take the extremes. Let's take first the two extremes and see what happens. So the first extreme, if the load is maximum, that means the load is infinity. In other words, that this part of the load does not exist. So we have an infinite load or open circuit, what we call open circuit. What happens? Well, there is no current going there because of the open circuit part. I equal 0. In this case, I load equals 0. So what is left this current. Now how much is this current? Well, it is the voltage over the resistance, that is 10 over 20, and that equals 0.5 amperes. So this is the total current that will go out from this battery or source. So the extreme load, a very big load, is acceptable because there is no problem. There will be no current that exceeds 2 amperes. Okay, what about the other extreme? If this current or this load, was shorted, So if we put a short circuit here, that means the load here now, the resistance of the load is 0. Well, in that case, what happens to the current? The whole current is going like that. So I load equal 10 over 0 of resistance in this, which equals infinity of current, and that is not acceptable. I mean, the fuse will burn down, so a very small resistance is not acceptable, in other words. Okay, now this example is very simple, really. Since the two branches are in parallel, so we know that, okay, sorry about this. This current here, these two guys are in parallel, so this current here is half ampere, we saw. What is left for this node to have 2 amperes, we have 2 amperes going like that, 2 amperes. Now there is half an ampere going here, 0.5. That leaves 1.5 amperes for the load. So IL maximum in a maximum instance will be 1.5 amperes. And we ask ourselves, if this is in parallel to this, that means the voltage drop between these 2 points is 10 volts. The maximum allowed current is 1.5 amperes. So the minimum allowed resistance in this case, R load, equal 10 over 1.5, and that equals 7 something. 10 divided by 1.5, 6.66. So it is 6.7 ohms. This is the smallest resistor that can be put here, and the current from the source will not exceed 2 amperes. If we reduce this a little bit, then the current here is going to stay the same, 0.5, because of the parallel connection. Here it is going to be more than 1.5, and we will have the fuse burned. Okay, that finishes this example. Thank you for watching.